Okay, so what these are doing, they are big lysimeters. They are not weighted lysimeters, but they are big lysimeters. They do have automated irrigation. What you see here is the outflow, so they won't. They will distribute the water in equal amounts. This is a pressure compensation.
Okay.
Okay. And the high-tech stuff is this one here. What it does is a tipping bucket is going like, when the water is coming out, it's going like plick, 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 plick. If you know the volume that each one of these buckets is holding, then with this electronic equipment, we're having in our computer the number of the tips. Tip, 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 tip. So we know exactly how much volume we have per unit time. So this is perfect for making a hydrological model, because we also have here you see a little panel it does. We have the wireless moisture sensors that is giving us the moisture content continuously every 7 minutes. Okay, so we're putting this one, but this one, κάτσε με τους χωρίζεις, Νίκο. Κάτσε να τους τα πω και μετά τα βλέπουνε. So we need this one here, so it doesn't, the wind doesn't affect the tipping. And here we have a system that is making a direct proportion of subsampling. So every day I'm coming here, I'm picking up the subsample, taking it, putting it in the laboratory, and then analyze it for all different kind of heavy metals.
You climb the ladder every day?
Eh?
You climb the ladder every day?
3 times a day. It's not a problem for us.
Oh, wow.
Yeah. We are supposed to get fit. Yes. So this is our high-tech equipment, and the biggest issue here is, if you notice, here we have, all these are leveled with laser. So they're absolutely level in all 4 corners. And from this part here, we can go from 0, from actually 2% to 35 degrees. So this one is an experiment that is going to keep on and make different hydrological models depending on the slope of the green roof. Now the whole here we have used the TPO material because it's one that is not supposed to hold or bind heavy metals. And here you see this one is a geotextile, and below it it's a full drainage simulation of a green roof.
Okay.
So we do have 3 different communities, plant communities.
You are recycling?
No, no. That's another project later on, if we decide to do. So we have oregano, turf grass, and sedum. 3 different plant species, and we will take and measure how much of dust and dust with heavy metals will retain on their surfaces. Then we will take samples from the soil and see how many heavy metals are in there, and then we will measure the effluent and see how much of the heavy metals are flowing, they're draining away from our system. So then we can somehow substantiate whether green roofs can be considered as effective biofilters in concern with heavy metals. We believe we have made a very clever setup. Apart from the 3 phyto communities that we have, we also have empty buckets. So we have a control saying how much heavy metals are coming from a system without plants.
Baseline study.
Yes. And also we have 2 empty buckets there and there in the 2 corners that we actually are simulating how much dust and heavy metals will come out from a roof without any type of vegetation.
As a control.
So we have 2 controls.
One substrate and one without.
plain substrate, and then
So you
nothing.
isolate the plants basically.
Yeah.
Yeah.
So we have all different levels, and then we can come to very rigid results, we believe.
Okay.
So
at
actually,
35 degrees inclination, don't
Yeah.
you have motion, movement of the substrate?
not really,
No?
not really. Especially if it is established with plants.
Okay.
That's why we are starting from low ones, and then. But
Okay.
as you will see on tomorrow's presentations, there are different materials that we can use if the inclination is getting too high. So what we're getting with this high-tech equipment is we're getting all different measurements right in our office. We don't have to come here, but unless we want to take the samples.